All right, hi, my name is Callie Burke. I am the lead at Kennedy Space Center for the International Space Apps Challenge project. And so thank you for joining us. Today we're going to be talking with Mike Conroy, who is going to introduce himself, and this is in relation to the Backfill My Model challenge that he created. So Mike, why don't you introduce the challenge and why it's relevant to your work?
Hello, my name is Mike Conroy. I'm from the Kennedy Space Center. I work in the modeling and simulation community and design and development of new space systems and new architecture systems and new ways to get to either other planets or what we're going to go do on other planets or moons. Modeling and simulation is a big part of the work that we do, and a lot of things exist in the 3D world with game-based tools or modeling engines or capabilities like that. There's also a lot that you would like to go have and be able to go touch and go see and go work around and go point to, which is where printing comes in and provides us a great deal of benefit in that domain. The 3D printed objects are a bit more portable than the environments that require your computer to go beyond it. It gives you something tangible you can look at, tangible you can feel, and is a bit better communications tool when you're able to go do those types of things. One of the things that 3D printers one of the challenges that we have, or things that we run into, is related to taking very, very large things and scaling them down so that they print okay on a 3D printer. You could have a building or a model or a space vehicle or something that is, 100 feet long or 200 feet long, and while it may be thick enough to go, or the parts may be strong enough to go work in that particular environment, when you scale it down to something that is only a foot long and all of the parts become 1/100th of what they were before, you don't have the model's not strong enough to do the types of things it needs to go do. Basically, they come apart or the printers refuse to go print them. Kelly was talking about an example, and I've got one here. This is a 3D model of the Orion spacecraft that we were using to go communicate to people size, fit, how stuff worked, how things fit. But when you print it on especially on the 3D color printers and the smaller ones like that, the materials get very, very thin and you get breakages. Material is just too thin to be able to go print. This one had to be manually redone in order to be thick enough, about 3/8 of an inch thick, so that it would be thick enough and not break when you tried to go print it or tried to go move it or tried to go use it. That manual process takes a great deal of time. We're looking for an ability or a tool or a capability or a process that will let us take a model that possibly comes out about this thick and turn it into something thick enough that we don't have to go worry about manually converting it or the products being very, very brittle or breaking when they come out of the different printers and the different materials. This is an example of something out of our color printer. The laser-based printers give you a product like this, and this is about as big a product as those printers create, which can give you the thin materials, but we lose all of the color information, and this is the largest part that those printers can go easily go print. So we can solve the thin material problem in some cases with a printer like this. However, we lose all of the color information, we lose a lot of the information we want to go transfer, and we can only have something this big. When we look at a print example from the larger printer that we like to go use, the one that printed this little Orion capsule, it can print a large item like our handy convenient lightsaber model, or other devices that are this big or even bigger. The build box is about 16 inches by about 10 inches by about 8 inches high. We want to shrink large spacecraft down to fit into that environment, but we also need them to be thick enough so that something like this doesn't happen. We don't have the tops breaking off of things when we try to go use them or try to go print them or try to go handle them. And that's the current thing we don't know how to go do. We don't know how to do that in an automated manner. We need an application, ideally, or some type of tool or capability that will go do that for us. So, Kaylee, that's a quick introduction.
All right, thanks, Mike. And so just as a note, this is one of the Kennedy Space Center challenges. And so there's 5 of them, included the Print My Rocket, Launch a Global Experience, geotagging, space and aviation. And so, and all of those will be, we will be having anyone who creates a video for them, regardless of whether or not you're nominated for global judging, go ahead and create a video, and we'll have a panel of experts. So for example, anyone who works on the Backfill My Model one, if you create the 30-second video for your project, Mike and a panel of experts will review them, and we'll select a winner for each of the 5 challenges. And then of those challenges, we'll select one as kind of the grand overall KSC challenge winner. And along with even though they're not a global winner, they'll get to come to a launch viewing opportunity with the global winners. And so expect that to be here at Kennedy Space Center. So just as a note for anyone who's trying with these challenges. So now we'll go to some questions for Mike. Okay. So, so you talked a little bit about some of the projects that you could use this tool for. How else does your lab work with 3D printing? Is it mainly just with these models to show people, or do you have other applications you use them for?
Okay, the major team we've got for these types of models with the color printer is how to envision what future systems would look like. How will this rover look? How will this spacecraft look? How will this area, if something is complex or difficult to go understand, either a 3D computer model or actually a 3D printed model is one of the best ways to go communicate and get everybody on the same page. When they look at it, they all see the same things and they can go discuss it. So we do that type of work in that arena. We have other areas where people are working with either flight vehicles or small devices, little rovers or little things like that are test cases for new technologies, and they'll use 3D printers to go actually print parts and print components that are used to go build those models. So you'll see a 3D printed part attached to a small motor to see how that structure works, or see how a model works, or see how a little rover works, or some small vehicle works. And we'll 3D print the parts as opposed to have to go send parts out to get built or use expensive metal parts. For the concept development and concept maturation, the 3D parts are very, very quick and easy to go make. They're very, very lightweight, and they allow us to go customize them afterwards if we need to. And if we need to go print more, we can very easily go print more. So kind of the entire range from building things that we're going to go put to work down to what are the next generation vehicles and systems going to go look like, and close to somewhere in there. Anywhere in between on the two of those, we either use the labs we've got here, or there are other facilities with sophisticated systems like Kennedy Space Center that will also print things out of carbon fiber, print things out of multiple different materials, print flexible items, print flexible materials along with structural materials, help you go make the equivalent of a hand. One of the models they've worked on was a human hand with the bones inside the hand. So you had a structural hand covered with rubber that let you go move it, go use it, but it wasn't something that was hard. It was something that was soft.
I think actually one of my roommates worked on that project for SmallWorks.
Yep.
She's an intern. Okay, are there any applications outside of NASA you could envision these kinds of tools being used for?
Any case where someone's trying to print something and scale something down. It could be a small building model, it could be a vehicle model, it could be a component model. Anytime you scale something down that in the real world may have been a particular dimension, if you scale it down too far, you suddenly get to a set of dimensions in the scaled down model that are just too thin to go print. Something that's 1/8 of an inch thick and you scale that down even 1/4 of its size. An 1/8 inch piece of steel or an 1/8 inch piece of aluminum is very, very strong. You start making things, a fraction of that, 1/10 of that size, you've got things that are just too small for any of the printers to go print and give you something you can actually work with. What you want to do is build up the backside of it, the parts that people can't see, make it thick enough that it can go print, and then we can go use the models much more readily, much more easily, and use the color printers and the higher end printers to do the types of things we want it to go do.
Thanks. So when your lab, since you guys work with a lot of different projects, if you get a new request from somebody, how do you guys work to understand the problem and develop a solution?
If a job is just to go print a 3D model, they'll work with whoever the person is, whoever the team is that needs the help to take the data file that they've got, and the first thing they'll go through is look at it and find out what the thinnest parts are. In some cases, we've got software tools that can come in and tell you that, yes, the printer will accept this model, or no, the printer won't because all of the parts are too thin, and it will go kick it back out. So if they've created, and we did this with the Razor model a number of years ago, or I guess last year, where the model that existed from the CAD systems had way too many parts that would not print, so we weren't able to go do it. And in that case, we worked back with the providers of the model to either modify the one that they had, or in some cases, they've got to start over from scratch and make a model specifically focused on being able to be 3D printed. So it's a bit of a challenge in there. If the customer doesn't have, or the people we're working with don't have a 3D model at all, we can then sit down with some of the 3D specialists and some of the 3D modelers, and they can go build up what the customer needs for whatever their product is. At that time, if we're building the model, we'll go make sure that the parts are thick enough that we can do the types of things that we need to go do, and make sure everything goes and works out that way. The challenge there is that takes time, that takes effort, that takes money. It'd be much, much better to work with the CAD models and the detailed system models that already exist and just fill in the parts that have an issue and need to be filled back in. So both ends, we'll either model it or we'll work with them to go make their model work.
Okay. So 3D printing, I mean, it's been around for a little while, but it's becoming, kind of exploded to become a lot more common recently. When new technologies like that or capabilities are developed, how does your lab work to incorporate them into your work?
The different technologies that are out there, we've got a very large number of the phase change, the ones that they extruded the thin plastic and go draw the model on the table. So we'll look at the various different products that are there. The ones that seem the most promising, we'll work to go get into the lab as quickly as we can, be able to go look at them, go work with them, and find out where they work and where they may not work as well as advertised. Some of the more expensive technologies will partner with others around the center. If do a study, go look at it, make sure it will do the types of things we want it to go do. And if it's an expensive piece of equipment, we'll go partner with several other organizations. Everybody will pay for a quarter of whatever that device is. We'll get it in, we'll set it up so that everybody can go use it, and the different people, different teams that bought it get to go use it. And then if others come in, that there's a way to go share the cost of the materials that are consumed when things are built, and to keep the lab running and keep it working that way. There are other technologies that are just too expensive to go use right now. So we'll work with whatever those technologies are. We'll try to find a way to go source that for the people that are on center. Yeah, it'd be really, really nice to go make something out of titanium. That's a rather expensive printer. We could set up a way to go, if you need something built, we can broker or work with you to go find sources to go get your part made and bring it back. That way people aren't trying to go figure out all about the technology on their own. We'll help in any way that we can go help.
Yeah. So yeah, it sounds like nothing new ever comes. You don't have to learn anything new in your job. You can rely on your old decades.
There's an awful lot of new to go learn.
So, when you talk about some of your projects, are there any that, as you dove into, was just really fun to get involved, as far as not really necessarily what you were doing, but just to learn a lot about a space project we have going on in the center?
One of the interesting ones that ended up working with the equivalent of a lightsaber printer was the need for a test device that came out of our Kickstart program. This is where new technologies come in or new ideas come in. It's a minimal amount of funding to go get started and see how your idea works. It had turned out to do what they needed. They need a very, very complex system to go work, need very, very complex parts made to go work with the systems they wanted to go do, and these were related to growing vegetables and growing plants for use at the space station. The ground system needed this complex part made. There wasn't any way to go make it, so they sat down and looked at, could we print this on the 3D printer? And it turned out they were able to go print it on the printer the way they wanted it to. They made it in two pieces and just bolted it together, and then attached it to a commercial hub that would let it go spin around. And it gave them the capability and to simulate how the plants would grow in 0G on the ground. And the 3D printed part turned out to be in the hundreds of dollars, as opposed to what it would have cost to get a very, very complex part made out of aluminum or some other material that they needed to go get it made out of. That's one of the ones that sticks in my mind. Is it was very, very neat to watch them go figure it out, go work with it. You had the plant physiology people, you had the hardware design people, you had the 3D modelers together with the people that understood the system, and together they said, hey, we can make something that looks like this. Will it work? And it turned out they all worked together to go identify what they really needed, how it would work, how they could play out it, and how to go make them good use of materials they needed to go work it. And they used it for testing for the garden wheel.
Oh, cool.
That was a cool one all the way through.
Well, that's all the questions I have for you today. Is there anything else you'd like to add or go into more detail on?
Nothing right now. We're looking for solving a very complex problem that is probably a little bit harder than it seems. So that's something we've been able to go solve, and I'm really looking forward to see how this community, the ideas they come up with, the methods they come up with, and the ways to go look at this that people come up with to go help us be able to much more quickly understand things, much more quickly print things, and create products that we can go use that are a lot more durable, both for our design and analysis, and also to help us with sharing what we're doing, sharing it with people, and getting more people involved in the problems that we've got.
All right. Well, thanks for your time today and for being one of the challenge owners. And as I mentioned, so there are five KSC challenges that we'll be reviewing all the videos for, regardless of whether or not you're nominated for global judging. So it's Backfill My 3D Model, Printed Rocket, Launch Global Experience, Geotagging Space and Aviation, and then I forgot the fifth one earlier, Space Route 66 regarding spaceports. So thank you everyone who watches us, and we look forward to seeing all your projects coming out this weekend. So bye, Mike.
Thank you very much.
Oh, did you want to show your picture real quick? I forgot about that.
If you could go bring that up, we've got an example problem case that we printed, or not that we printed, this is an unprintable device, but it helps you go drive the example.
And it's not an option. Okay, I'm going to share my entire screen. It'll take a second for it to come up.
That'll work.
And can you see it?
Yes, I think it's convinced that's who you are.
So do you need me to say it? Let me see. Oh, let me make mine the big one.
Yeah, you don't want to.
Oops. Let's see. Okay, is that it now?
There we go. So what you see here, if you're looking at this screen, is a structure that's intended to be about 20 feet high and about 20 feet in diameter. And it's a bunch of 1-inch long pieces of metal that would be curved in this particular shape and welded together. This is an example of either a structure or the center of a tank for a large space vehicle, or something else that has to go be reinforced. Well, having a 20-foot model is not going to do us, is not portable in any way, shape, or form. It is very, very, very expensive to go build. Having one of these that was about a foot tall or half a foot tall would be incredibly useful. But once I took this 20-foot device and made it a 10th or a 12th, or 7 or 8% of what it was before, all of the beam pieces would be too thin for any of the printers that we've got to go print. So we want to be able to shrink it down, but then find any of the areas that violate a certain, that are too thin, and just extrude them back, make them a little bit thicker going towards the center, or some type of interface that lets us go make those parts thick enough that they'll actually reliably print. And then we can go use the smaller version of the model to go help the analysis side, help communicate what we're doing. Or if we have to go integrate 3 or 4 or 5 different 3D printed parts, we can go build them, put them together, and see how the final device works out.
All right, great. So this is an example. So yes, we don't like to tote around 20-foot things just to show people what they'd look like.
It does not fit in checked luggage at all.
All right, well, thanks again, and we'll see everyone this weekend.
Thank you, everybody.
Bye.